Yeah, so welcome, my viewers, on today's lesson. This lesson is on Mr. Ignatius Wahome YouTube channel, YouTube channel for mathematics. So the question that I've provided here is question on 3 dimension. That is form 4, 3D, the topic that we call the 3D. And I've already provided the question there. So I've already provided the question there. So as you can see from the board. Now, so the question is like this, that PQRS V is a right pyramid on a horizontal square base. The square base of 10 centimeters. So the sides, these are a horizontal square base of 10 centimeters, 10 centimeters. Then the slanting edge, they are all 8. When you talk of right pyramid, meaning all the slant edges are equal. All the slant edges are equal. So therefore, question A, you are told, calculate 1 decimal place, the height of the pyramid. This is the perpendicular height of the pyramid. So this is what you're supposed to calculate, perpendicular height of the pyramid. So therefore, solution for this one, so this question number 1 is 2 marks. So part A of this question. Now, so this question, when you want to find the height of this pyramid, so the best thing is to find the diagonal. You can find PR ama QS because it's a rectangle. Sorry, it's a square. Then all sides are equal. So therefore, because it is a square, then that angle is 90 degrees. So can you start by finding PR? PR squared is equal to 10 squared plus 10 squared. Go this side is 10. So that you get PR squared. This 100 plus 100, that is 200. So PR will be equal to the square root of 200. So you can take your calculator and get square root of 200. This becomes 14.14. And because the examiner has told you to give your answer into 1 decimal place, give your answer as 14.1 centimeters. Sorry, this is the PR. This is PR. You just get the diagonal. The diagonal is 14 centimeters. So we can leave it as, we deal with 14 centimeters first of all. It goes to the diagonal, not to the height, not the final answer. So the final answer is the one that we round off. So therefore, PR is equal to 14.14. So therefore, what you do, you drop this height from the perpendicular height all the way from point V. There's V, let's say this point is O. VO is perpendicular to the line PR at point O. And because this one, they are equal, then O is the center, meaning PO is half of 14.12. So 14.14 divided by 2, this becomes 7.07. So when you want to find the height now, it looks like this. You are looking for this height, the height, that is OV. So VO, this is VO. So this is P. This is P. So VP is 8 centimeters. Now PO is 7.07. So what is the height? The height in this case, this forms a right angled triangle. So use what? Use the concept of the Pythagoras theorem. You say 8 squared minus 7.07 squared. Then you find the square root. That will be the height. So 8 squared is 64 minus 7.07 squared. This becomes 49.9849. So you get 64 minus answer. You get this becomes, the height is the square root of 0.151. Then you find the square root. The square root becomes 3.74 centimeters. 3.74 centimeters. But because the examiner said, give your answer to 1 decimal place, your answer. So the height, we take the height is 3.7 centimeters. So now we shall deal with 3.7. as the height. So the height of this pyramid is 3.7 centimeters. That is 3.7 centimeters. So that's what you're going to deal with. So that is question number A, part A of the question. So it is find the height of the pyramid. So now we go to the question number 2. Number 2. This one is now on the angle. The angle between a line. The angle between a line and a plane. The one that you're going to find. So we can lab this one now. We can lab this. And now lab this one because you already have the height. 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 So therefore, part B of the question is the angle between line VP and the base PQRS, the base. So this is the angle between a line and a plane. So when you're dealing with this question, the angle between a line and a plane, you are supposed to understand the angle between a line and a plane is the angle between a line and its projection on the plane. The angle between a line and its projection on the plane. So in this case, identify the line VP here and the plane PQRS So the projection is the shadow of the line on the plane VP PQRS. So you identify the projection of that projection. That in this case we call it the shadow. So in this case, note where the line V on this plane PQRS, line VP, this shadow will come along this line PR. So where does it make an angle of 90 degrees? It makes an angle of 90 degrees at VOP. The angle is VOP. So this was the angle between a line and a plane. You are likely to get a right angled triangle. Where does this V cast its shadow point V at this point at point O? So this VOP is 90 degrees. Therefore, the projection of VP on the base PQRS will be PO. That is VP, that is PO, because it makes an angle of 90 degrees there. So therefore, you find now the angle between a line and the angle between a line and a plane is the angle between a line and its projection on the plane. So in this case, the angle between the line and the projection will be, the required angle will be angle VPO. So if you draw again this right angle triangle here, this is V, P, na O. That angle is 90 degrees. So PO, our PO is 7.07. Our height is 3.7. That was the height. And the VP was 8. VP was 8. So this one, call it angle theta. So therefore, the required angle is VPO, angle theta. So in this case, you write now, you apply the trigonometry. The tan, the SOHCAHTOA. Sine, cosine, tangent. Sine, cosine, tangent. So you apply this concept. You say, now you check two sides. We can check the height. We can check the height. And now this opposite, and now the hypotenuse. So opposite, hypotenuse. So you can leave the adjacent. So you can use sine. The sine theta is equal to opposite 3.7 all over hypotenuse. So 3.7, you get 3.7. 3.7 divided by 8. This becomes to 0.4625. 0.4625. 0.4625. 0.4625. So 0.4625. So therefore, when you get this one, now you get the sine inverse. Sine inverse of 0.4625. The sine inverse. Sine inverse. So press shift sine 0.4625. Your angle is 27.55 degrees. But remember, the examiner gave out the instruction, give your answer to 1 decimal place. So therefore, our angle, we give it as 27.6. So our answer in this case will be 27.6 degrees. 27.6 degrees. 27.6 degrees. So therefore, that is a required answer for that part. So that is part A. So that is B Roman 1. B Roman 1. So therefore, that is what you get. Then the other one will be the question on the angle between the line VP. So line VP. So let's love this. So Roman 2, B Roman 2 is the angle between VP and line VR. The angle between two lines. The angle between line VP and VR. You can see the kind of the angle that you require. VP and VR. That is angle PVR. That is the angle that you require. So therefore, you draw this. This is V, P, and R. Where PR is a diagonal. Where diagonal was 14.14. And then these sides are 8.8. The slant edges, they are 8.8. So therefore, when you want to get this angle, the angle required now is PVR, because it is between VP and VR. It's angle VP. The angle between the angle is PVR. That is the angle. Now listen here. The properties of angles. Are the properties of chords. If these two sides are equal, and then you drop a perpendicular from V, it will automatically bisect this chord. So this line 14.14 becomes 7.07. So that you find this angle now, you call it angle theta. So that once you get angle theta, you multiply by 2 for you to get the angle PVR. So again, use SOHCAHTOA. Use opposite, hypotenuse, or channel adjacent. So again, use sine. Use sine to get this angle. So you say sine theta for this question, the sine theta will be equal to opposite 7.07 all over 8. In this case, why am I using that? Because I'm using the SOHCAHTOA, you can only use it when you are dealing with a right angle triangle. That's why I've drawn a perpendicular bisector there. So you can only use it when you are using the right angle triangle. 7.07 divided by 8. So this becomes 0.8838. So get sine inverse of theta of 0.8838. Shift sine 0.8838. So this angle becomes 62. This angle becomes 62.1. 62.1. So therefore now this is the angle. That's just angle theta, and this is 2 bisected. So the angle required PVR is 62.1 times 2. You get your angle is 124.2 degrees. So the angle required there, the angle that you are getting there is 124.2 degrees. 124.2 degrees. So that is how you work out that kind of question. Then the last question for that one is the angle between two planes. The angle between two planes. So you can finish writing that. So you can write that. So that is how you work out the angle between a line, two lines. The angle between two lines. So therefore, this is a property where these two sides are equal. the sides of this an isosceles triangle. If you draw a perpendicular from this point V to this line PR, it will bisect the line. So therefore this becomes 7.07, 98. Then this becomes a right angle. Use SOHCAHTOA to find the angle. Opposite and hypotenuse. You get U sine. Then once you get one of the angles, multiply by 2. You get that angle is 124.2 degrees. 124.2 degrees. So that's what you get. So then the last question here, the last question, we are going to find the angle between, so it is the angle between, so Roman 3, the angle between planes VPQ and the base, that is PQRS, the planes, so the base there. So therefore, now, so planes between, the angle between planes VPQ and the base PQRS, that is the plane VPQ and the base PQRS. So therefore, once you identify the planes, step number 1 is to identify the planes. You identify the planes. So when you identify the planes, the step number 1 is to identify the line of intersection. Line of intersection between the two planes. Line of intersection. So the line of intersection. The line of intersection between plane VPQ and PQRS is PQ. That's the line of intersection. That's step number 1. Identify the line of intersection. Identify the line of intersection. So that is PQ. Then you go to the property. Come to the property. The property that you must use. The angle between two planes. The angle between two planes is the angle between two lines. The angle between two lines. One on each plane that are perpendicular at a point at the line of intersection. At a point on the line of intersection. The line of intersection is PQ. So two lines, we have this plane P, V, PQ, na PQR. This plane V, VPQ, you can mark this center here and this point here, the midpoint. Mark the midpoint of that plane. So this point will come to the midpoint. This V will make an angle of 90 degrees there. Let's say this is point M. We can call this point M. And this is point N. And then this, now that's the plane VPQ, makes this line at 90 degrees. That angle will be 90 there. Then this line on this plane, at that point, the same point, it makes an angle of 90 degrees there with that plane. So therefore, our required angle will be VMO, which is also the VMN. So in this case, the easiest route to use is VMO. This is V, this is O, angle 90, 9 M. MO is half of QR, which is 5. That is 5 centimeters. Now VO was the height, 3.7. The height, 3.7. So therefore, our required angle is VMO. That's the angle between the two planes. That is the angle between the two planes. The angle between two planes is the angle between two lines, one on each plane, that are perpendicular at a point of intersection, on the line of intersection, that line of intersection, at this point. So this line, this VM, makes an angle of 90 degrees with PQ. And MN makes an angle of 90 degrees with the line PQ. So at this point, so the angle is VMN. The angle is VMN. That is the required angle. VMN. The required angle is VMN. So therefore, VMN, VMO, which is this one. So light SOHCAHTOA. Light SOHCAHTOA there. Light SOHCAHTOA, locus SOHCAHTOA there. So therefore, wachana hypotenuse. Leave hypotenuse. Now use opposite and adjacent. Opposite and adjacent. So you say tan of the angle theta now there, angle theta there is equal to opposite 3.7 or adjacent, which is 5. So 3.7 divided by 5. This becomes 0.74. That becomes 0.74. 0.74. So therefore, now find the angle. Find the angle. Tan inverse. Tan inverse of 0.74. Shift tan 0.74. This becomes 36.50 degrees. So therefore, our required angle VMO is 36.5 degrees. To add the decimal place, the angle is 36.5 degrees. The angle is 36.5 degrees. And that is how you deal with this kind of question. That's how you deal with that kind of question on 3D, the 3-dimensional question. So that is how you solve that one. So thank you very much for listening to Mwalimu Ignatius Wahome YouTube channel. So keep your subscription active and you get a lot of questions. So thank you very much. Thank you very much. Thank you very much. So all the best in your exams.